Now we are going to solve problems related to the stream function, right? This is the first problem. In this problem, a stream function is given by equation psi equal to 5x minus 6y. Psi equal to 5x minus 6y. Calculate the velocity components. That means u is equal to what and v is equal to what. Also magnitude and direction of the resultant velocity at a point, right? Apart from that, they want to determine the what is the theta, direction of the magnitude and direction of the resultant velocity. These two heads we are going to determine. First one is the what are the velocities, what are the component of velocity in the x direction, what is the component of velocity in the y direction, and also direction of the resultant velocity. These two we are going to determine here. Now we know one standard formula based on the stream function. What is the standard formula? V is equal to dou psi by dou x. This is one formula. And u is equal to minus dou psi by dou y. These two formulas based on the stream function. Now therefore v is equal to psi is given. This is psi is equal to 5x minus 6y. Therefore psi differentiate with respect to x. We have the velocity component in y direction. This is equal, therefore dou psi by dou x. Psi is nothing but 5x minus 6y. 5x minus 6y. Here differentiate with respect to x. This is equal to 5 units. This is equal to 5 units. And one more formula as per the stream function definition, u is equal to minus dou psi by dou y. This is equal to dou by dou y of psi nothing but 5x minus 6y. Right, this is equal to this 5x minus 6y differentiate with respect to y. This is equal to 0 minus 6. This is equal to minus 6 units. This is the value of u and this is the value of v. Another one is magnitude and direction of resultant velocity at a point. So we know the velocity at a point P equal to, we know one standard formula, velocity at a point P equal to ui plus vj. This is the formula. This is equal, what is u value? U is equal to minus 6i plus v is equal to 5j. This is the velocity at a point P is equal to minus 6i plus 5j, but resultant velocity is equal to, we know formula, square root of u square plus v square. Square root of u square plus v square, u is nothing but minus 6 square plus 5 square square root. This is equal to, velocity component is equal to square root of 61. This is equal to 7.81 units per second. This is the resultant velocity. Resultant velocity equal to 7.81 units per second. Here we have determined one is the velocity component in y direction, another one is the velocity component in x direction, and velocity at a point P, this is the formula, and resultant velocity is equal to, this is the formula, square root of v square plus u square plus v square is equal to, this is the formula, we know the u value and v value. Then finally we have the resultant velocity equal to 7.81 units per second. Another one, we are going to determine the direction. Right here already I have given one formula at the derivation of the streamline. At the derivation of the streamline, I have explained regarding one formula that is equal to tan theta equal to v by u. Tan theta equal to v by u. Here what is v? V already we determined, this is equal to 5 divided by, right here small mistake, this is minus 6, minus into minus 6, this is equal to plus 6, this is equal to plus 6, this is equal to plus, right? V is equal to 5 and u is equal to 6, 5 by 6. Therefore, theta equal to tan inverse 5 by 6. Therefore, theta equal to 39 degrees 48 minutes. 39 degrees 48 minutes. This is the direction of resultant velocity. Right? In this problem, they have given stream function psi equal to 5x minus 6y. Based on that data, what is the velocity component in x direction, what is the velocity component in y direction, the two are determined. And what is the direction of resultant velocity? We have determined resultant velocity, and for the determination of direction of resultant velocity, tan theta is equal to v by u. Based on this formula, we know the v value and u value that are substituting here. Finally, we have the direction of resultant velocity theta equal to 39 degrees 48 minutes. Right? This is about problem. Right. We are going to discuss about one more problem related to stream function. Right? What is the problem? If for two-dimensional potential flow, the velocity potential is given, pi equal to x bracket begin 2y minus 1. Determine the velocity at point 45 and determine also the stream function at point P. Right here, they have given velocity potential function, psi is equal to some equation, but based on this pi equal to some equation, based on this equation, we are going to determine the velocity components at a point 4 and 5. Right, velocity components at a point 4 and 5 we are going to determine based on the velocity potential function definition. U is equal to minus dou pi by dou x, v is equal to minus dou pi by dou y. Okay, very clear. But here they asked one more problem, that is stream function psi at a point P, and also determine the stream function psi at a point P. But here they have given velocity potential function, but we are going to determine the stream function. Right? We are going to solve the problem step by step. Right. First, we are going to determine the velocity at a point 4, 5. Right? This is the equation given here. Based on that, we know one formula, that is equal to u is equal to minus dou pi by dou x, and v is equal to minus dou pi by dou y. These two equations based on the velocity potential function definition. Right? This is equal to minus of dou pi by dou x of, what is the pi value? That is equal to, multiplied here, 2xy minus x. 2xy minus x. This is the pi value. Right? Now differentiate this pi value, differentiate with respect to x. This is equal to minus of 2y minus 1. 2y minus 1. Right? This is equal to minus plus, but that is equal to minus 2y plus 1. This is equal to 1 minus 2y. This is the velocity component in x direction is equal to 1 minus 2y. then we are going to determine what is the velocity component in y direction. The formula for the determination of the velocity component in y direction equal to minus dou pi by dou y. This is equal to minus of dou pi by dou y. Pi value, that is equal to 2xy minus x. This is given in our problem. This is given in the problem. Therefore, differentiate with respect to y. We have 2x minus 0 minus 0. This is minus, so this is equal to minus 2x. This is equal to minus 2x. The velocity component in y direction v is equal to minus 2x. What they asked here, determine the velocity at a point 45. Determine a velocity at a point 45 means x is equal to 4, y is equal to 5. Based on at a point 45, u is equal to what? U is equal to what we have here, 1 minus 2y, that is equal to 1 minus 2 into y is nothing but 5. This is equal to 1 minus 10. This is equal to minus 9 units. This is the velocity component in x direction is equal to minus 9 units at a point 5. And v is equal to minus 2x. Already we have here. This is equal to minus of 2 into what is the x value? X is equal to 4. This is equal to minus 8. This is equal to minus 8 units. This is the u value. This is the v value at a point 4, 5. Right? This is about first question. Next one, also determine the stream function psi at a point P, that we are going to determine here. Dou psi by dou x as per stream function definition, and u is equal to minus dou psi by dou y as per stream function definition. Now we are going to take this one. This is equal to u is equal to minus of dou psi by dou y. U is equal to minus dou psi by dou y, but u is equal to, we know one value, that is equal to minus dou psi by dou y is equal to u, that is equal to already determined in the earlier slide, that is equal to 1 minus 2y, or dou psi by dou y is equal to minus of 1 minus 2y. This is equal to 2y minus 1. Therefore, here dou psi by dou y is equal to 2y minus 1. This is the relation we have. Dou psi by dou y is equal to 2y minus 1. Now, this equation integrate with respect to y. We have therefore integral dou psi is equal to integral 2y minus 1 into dy. Right? What we have from this one, psi is equal to integrate with respect to y. This is the 2y, 2 into y square by 2 minus y plus constant of integration. Psi is equal to 2y square by 2 minus y plus constant of integration. But here this constant of integration is not function of y, can be function of x. Here we have only two components. One is the x component, another one is the y component. Therefore, this constant of integration is not function of y, because we have integrated with respect to y. That can be function of x. Right? Therefore, this is psi is equal to 2 cancel y square minus y plus k. This is equal to say k. Right. Now this equation differentiate with respect to x. This equation differentiate with respect to x. Therefore, dou psi by dou x is equal to differentiate with respect to x 0 minus 0 plus d dou k by dou x. Right. Already we know dou psi by dou x is equal to what? V. Dou psi by dou x is equal to V. We already determined V value. V is equal to minus what value we have? V is equal to minus 2x. Already we have. V is equal to minus 2x. Therefore, dk by dx is equal to minus 2x. Now we have dk by dx is equal to minus 2x. Now this equation integrate with respect to x. Integrate with respect to x. So this is equal to integral d k is equal to integral minus 2x dx. Right? This is equal to minus of 2x square by 2. 2x square by 2. Therefore, 2 gets cancelled. This is equal to minus x square. Therefore, this is equal to k is equal to minus x square. This is the value we have. Now stream function equal to y square minus y plus k. K we have determined here. Therefore, stream function psi is equal to y square minus y plus k. K is equal to minus x square. But we are going to determine the psi value at a point 4, 5. At a point 4, 5. That means x is equal to 4, y is equal to 5. Now, this is equal to 5 square minus 5 minus x square. X square is nothing but 4 square. Finally, we have the answer that is equal to 4 units per second. Stream function psi is equal to y square minus y minus x square. This is the equation. We are going to substitute the value. X is equal to 4, y is equal to, because the determine the stream function at a point p is equal to 4, 5. Finally, we have 4 units. Now we are going to discuss about some more problems related to the stream function. A stream function for two-dimensional flow. A stream function for two-dimensional flow psi equal to 2xy. Calculate the velocity at point P23. Find the velocity potential function psi. In this problem, they have given stream function psi equal to 2xy. Based on this equation, they asked that first calculate the what is the velocity at point. What is the velocity? That means what is u and what is v at a point 2, 3. And one more problem, find the velocity potential function psi. Based on the stream function, here we are going to determine the velocity potential function. Earlier case, they have given velocity potential function. Based on that, we have derived that is the stream function. Now this is reverse case. First, we are going to determine what is the component of velocity in x direction, what is the component of velocity in y direction. Right? As per the definition of stream function, u equal to minus dou psi by dou y and v equal to dou psi by dou x. This is the basic formula based on the definition of the stream function. This is equal to minus of dou psi by dou y. What is psi? Psi is nothing but 2xy. 2xy. Right? This is equal to differentiate with respect to y, this is equal to minus 2x. This is the u. And velocity component in y direction equal to dou psi by dou x, that is equal to dou by dou x of, what is psi value? 2xy, right? This is equal differentiate with respect to x, we have 2y. But in this problem, they asked that the component of velocity u and v at a point 2, 3. That means x is equal to 2, y is equal to 3. Therefore, velocity component in x direction u is equal to minus 2 into, what is the x value? 2. This is equal to minus 4 units, right? V is equal to 2y. This is equal to 2 into, what is the y value? 3. This is equal to 6 units, right? These are the velocity components in x and direction at a point p 2, 3, at a point p, that is 2, 3, right? This is the first question. Second one, find the velocity potential function, right? For the determination of the velocity potential function psi, but we know some formulas related to velocity potential function and stream function, right? Now we are going to determine the velocity potential function. Here they have given stream function. Based on that stream function, we are going to determine velocity potential function. We know some relations based on the stream function and velocity potential function definitions, right? U is equal to minus dou pi by dou x, and v is equal to minus dou pi by dou y. This is based on the velocity potential function definition. And u is equal to minus dou psi by dou y, and v is equal to dou psi by dou x. So these are based on the stream function definition. Now u is equal to minus dou pi by dou x, and u is equal to minus dou psi by dou y. Therefore u is equal to minus dou pi by dou x, that is equal to minus dou psi by dou y. Now we are going to determine the velocity potential function. Therefore we are going to take this value. This is equal to dou pi by dou x is equal to minus u, right? U is the velocity component in x direction, that is already determined in the earlier slide. U is equal to minus 2x, right? This is equal to minus of minus 2x. Okay, therefore dou pi by dou x is equal to minus into minus plus 2x. Now this equation integrate with respect to x. Then we have dou pi is equal to integral 2x dx, right? Differentiate this equation with respect to x, so therefore integral dou pi equal to integral 2x dx. Therefore pi is equal to integration of 2x, 2 is the constant, x is nothing but x square by 2, plus constant of integration. This c is nothing but constant of integration. Therefore pi is equal to 2 gets cancelled, x square plus c. Now we are going to determine the c, that is the constant of integration, based on the boundary conditions, right? Here this constant of integration is not function of x, that can be function of y. Therefore this equation is differentiate with respect to y. Therefore dou pi by dou y is equal to differentiate with respect to y. This is nothing but 0 plus dou c by dou y. Okay, but we know the value dou pi by dou y. Dou pi by dou y. What is dou pi by dou y? Dou pi by dou y. V is equal to minus dou pi by dou y. Therefore dou pi by dou y is equal to minus v. Therefore dou c by dou y is equal to, in place of dou pi by dou y, we are going to take, right, this is equal to minus v. That is equal to minus, what is the v? Velocity component in y direction. Already we have determined in the earlier slide. Therefore minus of v is nothing but 2y. V is nothing but 2y. This is equal to dou c by dou y is equal to minus 2y. Now this value is dou c by dou y is equal to minus v. V we know that is 2y minus 2y. This value is substitute in the standard equation. What is the standard equation? Pi equal to x square plus c. Pi equal to x square plus c, but c is minus, right, dou c by dou y is equal to minus 2y. First this one integrate with respect to y, then we have the c value. Now this equation is integrate with respect to y. Therefore this is equal to c is equal to minus 2 into y square by 2. 2 gets cancelled. This is equal to minus y square. Therefore c is equal to minus y square. C value we have determined here. The standard equation is equal to pi equal to x square plus c. Pi equal to x square plus c. Now therefore pi equal to x square plus, what is the c value? C is equal to minus y square. This is equal to x square minus y square. This is the pi value. Velocity potential function pi equal to x square minus y square.